get from the Smartboard notes if you need it. So we're just walking through the solutions. So we're on part C. Part C says the distance between the two curves. When you're in rectangular mode, a distance is perpendicular, right? It's the short. When they say the distance, they mean the shortest distance, that perpendicular distance. If we're talking curves, when you're in polar mode, everything's from the pole. So when you're talking about a distance, like if I'm going to here, then it's literally the distance along an angle, right? So the difference between the two radii is the distance, right? So like here, that's your distance, not the perpendicular distance, but that's your distance. Okay, so the distance between the two curves in polar form, you just subtract the radii. That's all you do. So when you subtract the radii, I can't say. Okay, so when you subtract the radii, there's your distance, and then you literally just find the derivative and plug in a -2. Right, or plug in the pi thirds and you get -2. So you got a point for writing out what the distance was, and a point for the derivative at pi thirds. That's it. What did you get?
My calculator got -1.999.
That's okay. And I know, one of the things I am seeing like crazy is, especially in polar calculators, they're not exactly perfectly accurate. There's a lot of rounding going on. So we actually had one student in core today who entered the exact same integral, literally copied it like one line to the next and hit enter, got 2 different answers. They were off by like the first 3 or 4 decimals I think were the same, and then it changed. I don't remember. So they are approximates. They're approximations. So you just, I don't know. Anyway.
So
how does the calculator approximate differently? Like,
well, I know that when you're doing derivatives, I remember when I was back younger, I was taught that a calculator for derivatives actually uses a difference quotient, which is just old-fashioned slope, but uses it for really, really small values around the x where you want the derivative. And so, yeah, it can't, how else is it going to do it, right? A 984 doesn't actually find the derivative function and plug in. It's just approximating the derivative with the difference quotient. So there will always be some approximation error. So apparently when you are in polar mode, the approximation error is a little bit larger and it's more visible when you're doing it. So there you go. So anyway, hopefully the AP exam readers would recognize that and accept. So anyway, okay. Now I did part D slightly differently from how they did part D. So it says a particle moving along this function, so d theta dt is 3. Find the value of dr dt when theta is pi 6, right? So I literally just found dr dt. I just differentiate with respect to t, right? When you do the derivative with respect to t and you do chain rule, you end up multiplying by 2 d theta dt, right? So that's where the d theta dt comes, and you just plug it in. Yeah, so it's just, to me, this is just a related rates question, right? So, huh?
How would they do it? Like, what other way is there?
Oh, well, they did it like this. They said, hey,
take dr dt.
dr, what did we want? dr dt? dr dt, whoops, oh my gosh, I'm speaking in, not, okay. dr dt is dr d theta times d theta dt. So then they just, since you have r, right, throw that in, plug it in, do the derivative at that point times 3.
It just seems like overcomplicated.
No, that's
No,
way
I think
easier.
it's fine. They're both fine.
Yeah, I mean, it
So-
works, but it's just like,
Yeah. So, anyway, either way,
it's actually the exact same one.
okay. So it's 2 points, 1 point for applying chain rule in the same way, right? Correctly, and then a point for the answer. All right, does that make sense?
Yeah.
What did you think? Your first AP free response polar area problem? Not so bad. It did, I know. Yeah, it really does. It looks worse than it is.
Before you stop, can I see the scoring guide for number
Oh,
4?
of course.
Or part D?
Yeah, it was 2 points, It was 1 point if you correctly applied chain rule with respect to t, and then a second point for the answer, which was -6.
Yep.
Yeah, I did it the other, I didn't do it that way, I just found the derivative the old way.
Okay, okay.
Yeah, so I did really DRD, which was fun. Alright, so today's lesson, we're doing a double lesson today.
I'll make it one day. Yeah, no one's looking.
Okay, so today, yes, go ahead. Today we're doing 10.6a and 10.6b, which means your homework is 10.6a and 10.6b, right? Yeah, yeah, so fun with homework tonight. These problems go faster than what you've been doing. You'll see, hey, Lila. So when you're working the problems, you'll see, they're gonna, the first couple will take a few minutes and then you're like, wow, these are really easy, right? And so students, the words like, are they really this easy came out quite a bit today, because they're pretty easy.
Our homework is all.
Catherine, okay? You look very sweet. Good, okay.
Wait,
Alright.
so then do we have homework this weekend?
Oh, yeah. Don't worry. I have plenty to keep you plenty busy.
Our homework is
Review.
In addition to the weekly quiz, right?
And the review for the final.
Look at all the
Yeah, and
Okay. Alright, well, your homework tomorrow night is final exam review.
Oh,
Because what I want to do tomorrow in class, tomorrow we do vectors. The lesson should take maybe 20 minutes, and then I have 3 AP free response questions, all vectors, that I want you guys to work through in class. And, because I was going to have that be your homework, but I decided I'm going to try to have that be classwork, and then give you an AP packet to do from home instead. So you get an AP packet plus your weekly quiz.
Oh, brilliant.
Yes.
What will the homework be like for the final review and AP review in general?
Same, more AP packets, it's just more AP exam practice.
Okay.
Yes, lots of AP, yes,
how hard is the final?
it's an AP exam.
It's tough.
But it's a reduced AP exam.
Wait,
is it
2 days?
It's 2 days. So each day you have 3 free response, and then one day you have 14 multiple choice, and one day you have 10 multiple choice. One of the things I have to talk to Mr. Thomas about is that Thursday is a shorter day. And so will you be able to fit a whole part into that shorter class period? So I have to ask him what his plan is for that. Yes.
Does he like choose all the problems from different AP tests, or is it just
No.
one?
No, I know where he got his problems from. You won't find them.
Let me
Yeah.
guess.
Is that a
Wait,
challenge?
Let me
Really,
guess.
it's
But
not
he
a
hand-
challenge, it's just that
Did he handpick them?
Instead of studying for the exam,
Uh.
I'm getting
no,
the entire
Just
they are
practice.
from a source.
Let me guess, it's the internet, and Mr. Thomas actually hacked into the College Board
Every
website to
single
get
AP
some multiple
practice
choice and
problem
response
ever.
questions that we will never get.
How did you know?
Because I'm part of the NSA.
Okay.
Let's go, Britt.
Yes, yes. Okay, they're actually on the internet, it says Mr. Thomas's final exam,
Oh,
right?
okay.
So I don't look it up.
Challenge
Okay, yeah.
It actually was.
Alright, so,
Something like somehow.
here we go. We're gonna do polar equations of conics. There are technically 4 standard forms, but I'm calling it 2 standard forms. You could have 4 if you want to think of the plus and the minus, which is a separate equation, right? Plus and minus, plus and minus. Okay.
It's a directrix.
So E is the eccentricity, and D is the distance between the pole, and I put the directrix, I should really put a directrix, because ellipses and hyperbolas have multiple directrices,
Oh, okay.
and only a parabola has 1 directrix. So, anyway, but yeah, D is the distance between one of the directrices and the pole. So, eccentricity and distance between the directrix and the pole. Regardless of the conic, one focus is always at the pole. This is really key. There is always a focus at the pole. Alright, little tidbits of information that will come in handy. If E is between 0 and 1, it's an ellipse. If E equals 1, it's a parabola. If E is greater than 1, it's a hyperbola. Now, E is the ratio of the distance from the center to a focus and the center to the directrix. So, I'm sorry, vertex to a focus, vertex to the, no, it is center, now I'm mixing myself up, I'm so sorry. Anyway, yeah, it's vertex. Oh my gosh, my brain just, literally, like I can feel the smoke coming out of my brain right
That's
now.
right.
Okay, anyway, so here's what happens. If you are on an ellipse, so here's a focus, the directrix, yeah, here's a vertex. So the directrix is farther from the focus, or from the vertex than the focus is. So you get this, this ratio, like if we call this A and D, or this would be C, right? So anyway, distance here to here, then this is always bigger than this, and you end up with an eccentricity that's less than 1. If you have a parabola, where you have, there's your focus, there's your directrix, the distances are equal. And so you get the eccentricity of 1. And then if you have a hyperbola, so there's the focus, the directrix is actually like really, really close. And so this is bigger, this is smaller, and then the eccentricity actually ends up being bigger than 1. So, anyway, not that, you don't have to know all that, I'm just kind of telling you, so. Anyway, so yeah, eccentricity, less than 1 ellipse, equal 1 parabola, greater than 1 hyperbola. Vertices are always, all the points are going to be written in polar form, aren't they? If the equation has a cosine, it is horizontally oriented. If the equation has a sine, it is vertically oriented. All right? No matter what the shape. So no matter what the shape, if there's a sine, it's going to be vertical. If there's a cosine, it's going to be horizontal. The only other thing, and we'll get more into this in a few minutes, and I don't know how much information I can spew out at you this quick, but the plus or minus, they tell you where the directrix is. Like, directrix is always perpendicular to the major axis, right? So if we have a parabola, right, there's the major axis, there's the directrix, right? It's always perpendicular to the major axis. If, like, remember, focus is always at the pole. Focus is always at the pole. So, if the directrix is below the pole, you would have a negative here. And that, it kind of tells you which way it's all going, right? If the directrix is above the pole, you'd have a positive there. And it would actually make the parabola point down. So, it tells you which side of the pole the directrix is on. That plus or minus. Okay, we'll get into it though. You'll see. It'll make sense when we do the problems. There we go. Alright, so... Wait. Don't look. There. Okay. Alright, so we are going to find the eccentricity and the distance from the pole to the directrix for the equation below. Then sketch the graph and identify the vertices. Alright, so we have the equation r equals 2 over 2 minus cosine theta. If you look at the standard forms, no matter what form it's in, what is in common to every form of these equations?
1.
The 1. It's always consistent that there's a 1 in the lower left corner. Which someone said, ooh, that's just like geometric series, a over 1 minus r, right? Same kind of thing. You get a 1 there, you're good. And then someone said, ooh, that's kind of like logistic differential equations, where you got the 1 plus b, right? Oh my goodness. Oh. Okay. So anyway, yeah. So it's the same kind of thing. So what drives, the way that you get it into standard form is you get a 1 there. So everyone take a second and figure out what you need to do to make that become a 1. who keeps writing Buteville on the board.
Oh,
Would it be more acceptable to do if someone wrote consoles instead?
Like happy hour there, he said, that's awesome, you go end up.
she's like, yeah, it's
What hour do you have? First hour? Is your break on it? Can you do that?
Okay,
You won't want to teach.
so a couple quick questions just by looking at this. Number one, is this, no matter what the shape, is it gonna be horizontal or vertical? It's gonna be horizontal, how do you know? Cosine, good. So if it is a horizontal shape, that means it's got a horizontal major axis, which means the directrix or directrices will be vertical, right? Will that directrix be to the right of the pole or to the left of the pole? It's gonna be to the left of the pole, and you know that because of the minus here. Alright? Okay, so first we need to get into blah blah blah. Did you all get that for your simplified equation? Good. Next thing you have to do is find E and D. E is easy, no pun intended, because it's always the number in front of the trig function. E for, well, E is it's actually, I learned something new about it, which I will show you in a few minutes, but E is actually of several different ratios. We always thought of E as the ratio of C to A, the distance from the center to the focus and the distance from the center to a vertex, but it's also the ratio of C to, let's see, to D, not exactly D, but to something related to the distance to the directrix. So those ratios actually end up being the same value, which I didn't know until today. So now we know, right? Yeah, the more we know.
Doesn't it tell you how to search for something?
Anyway, and then for an ellipse, yeah, it tells you how, like, as E approaches 0, you get a circle, and as E approaches 1, you get a line. It tells you the ovalness of the ellipse, the ellipsisness, the ellipsicity.
Ellipsis.
Oh, that's the one, that is the one.
That's what it is now.
Alright, so, what's E?
1/2.
What's D?
2.
Okay, and we know this is an ellipse. How did I know that this is an ellipse?
Because it's less than
Between 0 and 1.
Yeah, because E is a half. It's between 0 and 1.
And
By
maybe
the way,
less than 0.
good question. I was just about to say that. You're so good. Okay, E and D are always positive values. Always positive values, all right? E is a ratio of two distances, D is a distance. They're always positive
D
values.
is a displacement. Oh no.
D is a distance. Okay.
I just.
Or it
Okay.
could also
I did.
be negative 1/2 because it's 1 plus E plus
Yeah.
No, E is always positive. E is a positive value. The plus or minus just determines location, but it doesn't change the value of E. Yes,
How do you know E is 1/2 and not 2?
because E is always the number in front of the trig function.
Oh, okay.
Yeah, guys, you have Mr. Ed on top, right? So, you have ED, right? Okay, so Ed is on top, but E is also right here. It's always the number in front of the trig. Okay. Quiet, please. All right, next thing you have to do is graph. When you are graphing one of these guys, first of all, usually for this one it really doesn't matter, but for some of them when you get into the real fractiony stuff, it's usually easier to just plug into the original because you have less fractions. But anyway, when you are graphing, I have found that I was easily able to graph every conic just by plotting the 4 points on the 4 axes. So go ahead and take a second and figure out your points at the 4 axes. So you're going to plug in thetas of 0, pi halves, pi, and 3 pi halves, and we'll see, we'll take it from there.
Why are we doing 0 and 5? Why are we dividing those in pi half?
Because this is full.
Is there gonna be,
Oh, right, 4, yeah.
is there gonna be graphing on tonight's homework?
I think so.
No.
Oh.
I had another stack and it disappeared, so I have not been able to find
Dolls on
it.
the
Polar
blackboard.
graph
Yeah.
paper.
They're
someone
selling it at
stole
full
the polar
price.
graph paper.
I didn't
But
see you
here's
buy
what I
polar graph
did,
paper.
okay, guys,
Oh.
so, and just so this is on the video too, because I'd like this to be on there, although I put it on the core video today, but on my website, so first of all, under chapter 10, there is polar graph paper, so you can just print some if you need some.
Isn't the nice stuff?
No, it's the yucky stuff, but you can always like go online and find good polar graph paper for that. But then the other thing, just to point out to everyone, is if you need help with some of the AB topics that we haven't done for a while, I put all my old AB topic review sheets online along with answer keys, right? And the answer keys aren't just the answers, they're the whole solutions with every problem worked out. So, no, this is old stuff, I didn't do it. So, anyway, okay, so anyway, if you click on any of these, what I did this a number of, maybe 5 years ago, is I went through all of the old AP exams, like say for tangent lines, pulled every single multiple choice and free response problem that involved tangent lines, and then type them into one document, and I show you on the problem like what year it's from and which problem it is, right? And then you can look at the answer keys also. So if you want multiple choice practice, it's there. If you want free response practice, it's there. But that's all there if you need some help with that. All right, so getting back to the problem. Okay.
What'd you say?
So has everyone grabbed the 4 points?
Which?
Oh, grab.
Yeah.
Oh, I just wrote that.
Oh, go ahead and plot them. Take a second and plot them.
Oh, dude. You can do that.
They're not like crazy hard. I mean, they're mostly just images. It's not like. Did you all plot the points?
Nope.
Plot the points.
I don't believe in graphs.
To plot points.
Yeah. Okay, so if I would actually make my answers a little bit bigger, but so here are things, so I know that my angle is and my radius is zero. So here my angle is pi half, and I'm gonna go up 1. Here my angle is pi, and I'm gonna go out 2, right? 3 pi half. R theta. So think of it theta r. Angle of radius. This tells you where, this tells you how far you go out.
Oh, so this is.
Yeah, it's cool. It's just like the circle. Yeah, this is the circle.
So,
Yeah, yeah. Well, you can do it. Okay. Alright, now, the final shape, when you plot your 4 points, you get this, 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 and this, right? Now, you can usually kind of freehand a fairly decent ellipse out of those 4 points. But if you want a better ellipse, here's something to keep in mind. The focus is at the pole, right? And ellipse has a second focus that's on the other side. So this focus is 2/3 away from this vertex, right? So I could go in 2/3, have the other focus, and then from the focus go up 1, down 1, and get more points, right? Or if I want it nice, because ellipses are symmetric. So, anyways, if you want to make it look nice.
Wait, so why would you need to find E and D in this case? Why not?
Because the question says, what's E and what's D?
That's kind of lame.
Okay, so anyway, by the way, quiet please, your D here is 2, but it's a minus, so that means that we're gonna go 1, 2 to the left, and that would be one of our directrices, right? There would actually be another one over here.
Do we always graph the director? Doesn't matter.
The ellipse.
Alright, okay. There probably will be a graph another 8.
Something tells me this is not
Probably not.
Anyway, okay, so there you go. Yeah. Okay. So there you go. That's it, and by the way, if you notice, so the distance from a vertex to the focus is actually less than the distance from the vertex to the directrix, which is how you get that C less than, or that E less than 1. It's that ratio. Unless it's the center. I'm still not 100% convinced I'm not but talking and that it actually is the center. Either way, center to the focus, center to the, I think it's center to the focus, center to the directrix. I think that might be it.
Oh, then you don't graduate.
Not impossible. I'm terrible.
Well, that's like one thing.
Okay, so anyway, alright. Try this. Okay, try another one. Find E, find D, sketch a graph. I'm gonna look it up. Just to make so I can clarify the video.
Can you stop?
Wait, what?
Don't ruin the surprise.
Why did you just do it?
We should. You bet.
I say we rebel.
Yeah.
Against questions like this.
Okay.
You guys?
Siri, what are you doing?
Don't make fun of Siri.
Siri is not an idiot.
Yeah.
She's
Right.
worse.
Tom,
Alright.
don't hate Siri.
Hate you.
Says you.
Yeah, hate the player and
Says you.
That's how you make your own.
This is the truth.
I got that. You have to love this place. Reached an impasse.
only got 3 minutes.
Is that a vocab word? Impasse. It is. I like saying impasse.
It's the center. It's the center. So, guys, I'm so sorry. It's not a vertex. It's the center.
this doesn't
Oh,
exist.
let me
What do I do?
unfreeze so you don't all see the save the date thing.
It doesn't have like.
Okay, so it's the center. It's the center, right? So E is the ratio from the center to the focus and the center to the vertex,
Yeah.
or center to the vertex, center to the directrix.
Oh, send it to the vertex over the.
Over the center to the directrix.
Okay.
So you can either do center to the center to the focus, center to the vertex, which is C over A, or you can do center to a vertex over center to the directrix.
Okay, wait. How'd you grab this? 'Cause it's-
No, that's just, I wanted to make sure I told you the right thing.
Oh, okay.
Right?
Where?
You know, for the video,
Why now?
for posterity. Okay, so what for this one, what's E?
Which means there's no point in finding.
1, what's D? 6. Is this horizontal or vertical? What type of a shape is it? So we have a horizontal parabola. How do we know which one?
Because E is equal to
Because
1.
E is 1. If E is 1, it's a parabola.
I got it.
Yep.
Oh, I knew that.
Okay. So if you plot some points, did you guys all plot points?
Yeah.
Oh,
Yes.
I actually did.
Okay, alright. So if you plot points, you actually just get those 3, right? Because if you plot at, which one, pi? Yeah, you get undefined, which makes sense because it's a parabola, right? Okay, so you get your 3 points. You only need 3 points for a parabola. But if you want, like, just know that's the focus, right? The focus is always inside the parabola, inside the U, so it just kind of helps you know you're wrapping around the focus, right? And then for this, it's positive, so the directrix would be 6 units this way, which makes sense, so that distance and that distance are equal, yes.
So for directrix distance, it's distance from the center, not from the edge of the parabola or ellipse.
Yes, it's distance from the pole.
Okay.
Not from the center,
The pole,
from
yeah.
the pole, from the pole. The D, guys, is the distance from the pole to the directrix. D, distance from the pole to the directress, yes.
And if it was 6 over 1 minus cosine, it'd just be like flipped.
The whole thing would be
across
flipped
the-
around,
Okay.
yeah.
What about
Alright, good. Okay, E and D are always positive. If you see a negative on the top here with this number, that does not mean that E or D are negative. All it means, put the negative in front and just think that whoever wrote this said, hey, I want to flip this one over. So that's all, right? E and D are still positive, but there's just a negative reflection going on when you graph it. So go ahead and find E, find D, bless you, find E, find D, sketch the graph.
Yes.
Oh, well, E, yeah.
Of course. Well, you need to graph the directress. So yeah. That's the little dotted line. Wait, is the negative reflection over the x-axis?
The negative, yes, would be, although it's weird because this is polar,
Yeah. Okay.
so
the
you might have to do a.
theta axis.
Yeah.
I don't even know.
Yeah.
Wait, what? That doesn't make sense either.
It's just gonna reverse the whole thing because all of your radii will be opposite sign.
That's stupid.
Is this
No,
third?
Isn't, yeah, 6 sevenths.
Yep.
You know your E, and remember that ED equals the number on top.
Yeah, I saw
8 instead of 7
I know,
Oh.
did it feel good? Yeah, yeah.
2.
That's why this lesson will feel easy because there's no calculus in the whole lesson. So, which is why I don't think this is unreasonable.
Like,
Yeah.
oh, I remember how much I hated that when I did that. But it looks so much nicer now.
Yeah.
7/3 and 8.
I don't understand the graph.
2 divided by 7/3.
Did you plot your 4 points?
That's 2
Yeah.
times 7.
And you know where the focus is, right?
Yeah. But what is the focus? It's a passive.
It's inside one of the curves.
Wait, we have to find the pole.
No, just
Wait.
no, the focus is at the pole.
So,
But then that really doesn't make sense, because I got 4 points.
Right.
Wait, no, did I do that wrong? Oh, I didn't do that wrong. Wait, no, wait, hang on. Actually, I did do it wrong.
Okay, did you all get this, the standard form correct?
Yes.
Okay, so your E is 7/3, your D is 6/7. The conic is a hyperbola. How do we know it's a hyperbola?
Because E is greater than
It's
1.
greater than 1, yep. Okay, so when you plot your 4 points, the points that you actually get are, you get 0, -2, and you get pi, -2. So it reverses those two, which actually has no relevance at all on the graph. But it does have relevance this way, which is at pi halves, you get thrown down to -3/5. And at 3 pi halves, you get put to 3 halves. So you end up down there. And so since this graph has y-axis, I think it does a total flip of everything when you have a negative in front of a polar curve. It's going to change everything, because it changes all the radii, right? So everything gets flipped. But this has symmetry this way, so it's irrelevant for the y-axis. I can't call it y-axis, but anyway. All right, so you have these 4 points. So if, say you're just looking at a graph and you're like, all right, I have those 4 points. What do I do with that, right? Okay, well, just know there is a focus at the pole, right? And we also know that it is vertical, it's a sine, right? So that's our major axis. So since that's our major axis, we know then that these are the vertices, and it's got to go this way because a hyperbola always wraps around the focus. Then there would have to be another focus down here, and then you wrap around that one. It's symmetric.
Wait, what did you flip it?
You just plug in points.
When you plug the points in, the negative pushes them. Yeah. So there you go. The directrices for this would actually be both squished in the middle here.
Oh, okay.
if you want to know that. All right. Good, good, good. All right, so that's it for that part.
Oh, yeah, there's another one.
So now,
So is there a lot of homework today?
there's some.
That was like the most inconclusive.
Okay,
So we're gonna do
Now-
part B in 10 minutes.
yeah. Okay, now we're gonna do it backwards. So, the way that we do it backwards is we're given E and D, basically, and we have to write the equation. So I'm gonna give you a little bit of guidance, all right? So, first one, you try right off the bat, but it's you try with help. So, write a polar equation for the conic section with the focus at the pole, an eccentricity of 1, and a directrix y equals 1. Ooh, Raymond is doing something really smart.
What? Oh, what?
He just went like this.
Yes.
Yeah.
Why did he go like this?
That's like, because that's the perpendicular, it's like
That's the
perpendicular
directrix,
and like,
right? Y equals 1. So which way is the major axis then? It's vertical, so this is going to be a
Sine.
right? Okay. So we already know which trig function it is. It's going to be a sine. Okay, tell me something else we know.
We're gonna have a 1.
Okay, we know that E is 1, so the number here is 1, right? There's always a 1 here. And there's a 1 on top because that's ED, right? And the distance from the pole to the directrix is 1. So the only thing you don't know is if this is a plus or a minus. Remember, if the directrix is above the pole, it's a plus. If the directrix was below the pole, it's a minus. So an easy little trick that I wrote down here is that if there's a plus, if it's positive, you use a plus. If this is negative, you use a minus. Right? Yeah. I mean, it's really that easy, right? Okay, so this equation, 1 over 1 plus sine theta, bam. What type of a conic is this? This is a parabola, because the eccentricity is 1. Okay, is this horizontal or vertical? Vertical. Okay, here's the question of the day. Is this parabola going to open up or open down?
Down. Because the directrix is
No,
down.
just you drop the top one.
The directrix is above.
It's opening down, right? It's opening down because the directrix is up above it, right? And the focus is here, so the parabola has to, remember, it has to enclose the focus and open away from the directrix. So, yep, so it's opening down. All right.
Is that it?
Okay, try one.
And then
You whispered.
Write a polar equation for the conic with focus at the pole, an eccentricity of 3/4, and a directrix y equals -2. By the way, psi y coho still works for these.
What?
I'm always gonna remember that.
I know,
What's sine
right?
coho?
If you see a y, you use sine. If you see an x, you use cosine.
We literally have it. We've never heard of it. Unless I'm
Yeah.
We
I
made a
open
big
up
deal about the
videos.
fact that it says
Do you have to simplify any fractions on the top?
I like to simplify.
Okay.
I don't like to have complex fractions. So I do like to simplify. Especially, it's not hard to simplify.
Yeah.
Oh, because it's what?
Now, since y equals -2, does that mean your d is -2? No, d is always positive, right? So d is 2, e is 3/4. Plug them in. Kabam. Does that make sense?
Everybody copy my work.
I did copy your work. That's, yes.
Wait.
I went over, I don't know if you know, but like this wasn't there. I was looking at your paper and I quick typed it.
Right, oh wait, how is,
Okay?
how is E equal?
You have wicked eyesight.
E is not 3/2. E is 3/4.
But E,
This is Ed.
and D distance.
D is the distance from the pole to the directrix, so it's always gonna be this number.
Oh, okay.
Yes.
Can you leave it on the left side or you have?
Yeah, but it's like a,
Why is it?
it's not nice.
What?
This is so much better.
Because D is always.
Right? Okay, what shape is this? What type of conic? This is an ellipse. Hey, is it horizontal or vertical?
Vertical.
Okay. Alright. Try one more?
Oh my gosh.
I actually have two more for you to try.
One more.
One
We only
more.
have 4 minutes of class left.
It's a nice day outside.
These take 40 seconds.
One more turn.
Okay.
No, not one more.
That is almost over. Oh, yeah, I know. Math.
Oh, no. It is cosine.
He's using sci-fi coho. Right? Sci-fi.
I get sci-fi. What about co-ho?
That's okay.
Cosine horizontal.
Oh, horizontal. Wait, when did you say that?
I don't know, sometime this week.
Yeah, I still see them on that.
3 days. It was when we first learned polar. I think it was last Friday.
Oh, that's why it was gone.
Yeah.
Yeah.
Good.
Okay, so E is 3/2, your D is 1, so you get that. Right? What kind of a conic is this? Hey, is it horizontal or vertical? Horizontal. Good. I have a challenge problem. Now, there are several ways to solve this problem. One way uses prior knowledge. If you have no prior knowledge, you can still solve it. And the way that I'm going to show you, which is not in the solutions, so if you want to solve it with no prior knowledge, write out a shell of the equation. And I'm going to give you a tiny hint, but so we know R is ED over 1 plus or minus E. And we do need to know if it's sine or cosine, right? Okay, these are the vertices. Vertices are at 2 pi halves, 4 3 pi halves, right? So is this going to be a sine or a cosine? It's going to be a sine because it's a vertically oriented thing, right? Okay? Because those are your vertices. Vertices are on the major axis. Okay? Yeah, you can only have 2 vertices. Right? If it's an ellipse, those other ones are called covertices. Yes.
Ellipses in the, okay.
Yeah. Okay. So anyway, so there you go. When you're given an equation of a directrix for these guys, okay, remember that's the focus. The directrix is always going to be, how do I say this? On the side of the ellipse where it's closer to that focus. Do you understand what I'm saying? Like it won't be down here. Since this ellipse is kind of lofted this way, the directrix will be on this side. I don't know if that makes sense or not, but it's true. So anyway, so I know, like for me, from sketching a quick graph, that it's going to be a plus. Now, if you know nothing else, you can literally plug in your R theta and then your other R theta, and you have actually a fairly easy system that you can solve. Okay, yes?
What if it's like centered, so it's the same distance on the side?
Remember, you can't be centered because it has to be a focus at the pole. There has to be a focus at the pole.
Wait, why does there have to be a focus in the pole?
Why does there have to be? Because that's how these equations are written. They force the focus to be.
Been over you for
Any equation in this form, the focus is at the pole.
Why is that?
I was getting quiet. Alright, so anyway, if you, for the video, see, please, quiet. For sake of the video, if you want to check your answers, that's your final answer. So your E is a third, your D is 8, you get your final answer. Have a wonderful
Oh, yeah, but I never touched the book, I didn't read it.
No, I'm here, I'm always here.
I just